All right, let's jump right in. Have you ever just stopped and wondered how our digital world actually holds itself together? I mean, how do these massive global systems handle millions of things all at once without just crashing? Today, we're going to pull back the curtain on the super clever architecture that makes it all work, from sharing a huge workload to creating something with unbreakable trust. Seriously, just think about your bank for a second. Picture it. It's payday. Millions of people are getting deposits, paying bills, zipping money back and forth, all in the very same instant. How does your banking app not just melt? How does it keep track of every single penny for every single person perfectly? Well, here's the thing. It's not one computer. No single machine on the planet could handle that kind of pressure. It would get overwhelmed in like a nanosecond. So to solve a problem this huge, you need a totally different way of thinking. You don't need a superhero. You need a team. So our first stop on this journey is figuring out how to share that workload. If one computer can't do the job, the most logical thing to do is get more computers to help out, right? This is the core idea behind what we call a distributed system, and it quietly powers so much of our daily lives. The solution has a name. It's called a distributed application. And honestly, the concept is beautiful in its simplicity. It's just software that's built for teamwork. Instead of one computer trying to juggle everything, the big task gets chopped up into smaller pieces and spread out across a whole network of them, all working together to get the job done. And the crazy part is, you're using this technology all day, every day, probably without even thinking about it. When you're scrolling through your social media feed, that's a distributed app. Making a phone call, you're tapping into a huge distributed cellular network. That online bank we talked about, or even the system that connects all the checkout lanes at the grocery store. It's all the same principle: teamwork and sharing the load. So how does this big team of computers stay organized? Well, it all comes down to layers. At the top, you've got the app that you actually use. But underneath, there's this critical layer called middleware. Think of it like the project manager, directing traffic and telling each computer what to do. Then, of course, each computer has its own operating system, and the whole thing is connected by a network that lets them all talk to each other. It's a really elegant system. Okay, so we solved the too much work problem. Fantastic. But in the world of technology, when you solve one huge problem, you often create a brand new one. And this new problem is arguably even trickier. And this is the million-dollar question, right? If your bank balance exists on a dozen different computers, how do you know for sure that they all have the same correct number? How do you stop someone from intercepting the data, or worse, sneakily changing a record on just one of those computers? How do you build trust when everything is spread out? The answer to this massive challenge of trust is a technology I am positive you've heard of: blockchain. It was literally invented to solve this exact problem by creating a totally new, incredibly secure way to record information. Now, at its heart, that's really all a blockchain is. It's a database. It's a place to store information. But it's the way it's built, its fundamental structure, that makes it a total game changer. It's designed from the ground up to be secure and trustworthy. So how on earth does it actually build that trust? You know, the best way to get it is to just build one right now. It's actually a pretty straightforward three-step process. First step, step one, you take a bunch of information, let's say a group of financial transactions, and you gather it all together into what's called a block. Just think of it like a single page in an old-school accounting ledger. We're just writing down everything that happened. Then, step two, once that block, that page, is full of information, bam, it gets sealed. It's given a unique, super complex mathematical signature. You can think of it like a high-tech digital wax seal. And once it's sealed, that's it. It's closed for business. Final. And this is the magic trick. Step three, that brand new sealed block gets cryptographically linked to the block that came right before it. It creates a chain of dependency. Each block is essentially holding hands with the one before it, forming a chain of blocks. And that's exactly where the name blockchain comes from. This simple but brilliant structure of blocks linked into a chain is what gives this technology its superpower. It's the feature that finally solves our big problem of trust. I mean, check out this line from our source material. Because each block is linked to the last one, you can't go back and secretly alter an old block. If you tried, you'd have to break that digital seal, which would instantly break the link to the next block, and the next one, and the next one. The entire chain would shatter from that point on, and everyone on the network would know. the information becomes, for all intents and purposes, unchangeable. And that gets us to the fundamental difference, doesn't it? A traditional database is like writing in pencil. You can always go back, erase things, change them, but a blockchain is like carving that information into stone. It is permanent. It creates a shared digital record that everyone can trust, precisely because no single person can change it. So who needs this kind of power? Well, this brings us right back to where we started. Banks and financial services are using this to create secure, unalterable records of who paid what to whom. But really, anytime you need to share and record digital information securely without a central gatekeeper, blockchain offers an incredible solution. And that really leaves us with a final fascinating thought. We started this whole journey talking about bank transactions, but this technology goes so much further than just money. Think about things like property deeds, voting records, our own medical histories, even our digital identities. It really makes you wonder, as more and more of our lives move online, what is the most important information that we should be protecting with an unbreakable chain?